Greetings, gear enthusiasts, and welcome to a gear lover's dream session. Today, we're delving into the mesmerizing realm of gear terminologies, leaving no gear unturned. Whether you're a mechanical prodigy or just gearing up your knowledge, this encyclopedic journey will equip you with a comprehensive understanding of gears. Let's jump right in. A. Gear ratio. The gear ratio is the bedrock of gear systems, representing the ratio of teeth between two meshing gears. This ratio governs the speed and torque relationship, determining how one gear drives another. High ratios mean more torque and less speed, while low ratios result in higher speed and less torque. B. Backlash. Backlash is the wiggle room between gear teeth when they're not in engagement. A controlled amount of backlash is vital for smooth operation, allowing for lubrication and thermal expansion. Excessive backlash, however, can lead to inefficiencies and noise. C. Center distance. Center distance is the distance between the centers of two meshing gears. It influences tooth engagement and gear performance. Incorrect center distance can result in increased wear and decreased efficiency. D. Diametral pitch and module. Diametral pitch, DP, and module are measurements of tooth size. DP represents the number of teeth per inch of pitch diameter, while module indicates the ratio of pitch diameter to the number of teeth. These values are critical in gear design and matching. E. Effector pitch. Circle. In planetary gear systems, the effector pitch circle is a virtual circle that represents the contact point between the planet gears and the ring gear. Understanding this circle is key for calculating gear ratios and planetary gear BHA. E. Effector pitch. Circle. In planetary gear systems, the effector pitch circle is a virtual circle that represents the contact point between the planet gears and the ring gear. Understanding this circle is key for calculating gear ratios and planetary gear BHA. F. Face width. Face width refers to the width of gear teeth along the gear's axis. It influences load distribution and gear strength. Proper face width is essential to prevent tooth breakage under load. G. Gear train. A gear train is a series of interconnected gears that transmit motion and torque from one shaft to another. It's a fundamental concept in mechanical systems and offers various combinations for achieving desired outcomes. H. Helix Angle. Helical gears have slanted teeth, and the angle of this slant is the helix angle. It's a significant factor in load distribution, noise reduction, and overall gear performance. To quieter and more efficient operation. J. Jumping teeth. Jumping teeth occur. Its gradual curve ensures smooth contact and minimizes abrupt forces during engagement. 1. Involute Profile. The involute profile is a widely used tooth shape in gears, leading when the teeth of gears intermittently lose contact due to excessive load or K. Keyway. A keyway is a slot on a gear shaft or hub that fits with a corresponding key to prevent relative rotation between the gear and the shaft. It's crucial for transferring torque effectively. L. Lubrication. Proper lubrication is vital for the longevity and efficiency of gears. It reduces friction, dissipates heat, and prevents wear and corrosion. Monsieur meshing. Meshing is the interaction between gear teeth when they engage. The quality of meshing impacts gear noise, efficiency, and lifespan. Correct meshing ensures optimal power transmission. Conclusion. And there you have it, an all-encompassing journey through the intricate world of gear terminologies. From gear ratio to meshing, you've acquired the tools to decode the language of gears. Be sure to subscribe, like, and ring that notification bell to stay connected as we continue to unravel the mysteries of mechanical marvels. Until next time, keep exploring, keep learning, and keep those gears in motion.